Welcome back in this new video, and today I want to show you how to create the custom wind side Pyro Solver. And for do that I want to start with the preset essentially, because it's not needed to create from the scratch the setup, but the only part I want to concentrate more is how to create the my custom wind. You can use that also for control and other things, like for example you can use also for reduce the velocity or increase the velocity, or for create the custom drag, for example. I use that techniques in more shot inside the studios, essentially for create my effects for control, for example the wind, custom wind. It's normal tools I use at more situation. By the way, we can jump inside Houdini. We can close our about for Houdini 21, and we can start with the below smoke preset here. I want to use the preset from the DOP because it's create essentially the part, the DOP network here outside, and for this case it's very comfortable. I want to close the shelf for have more room. And we can see our simulation is that is very classic simulation, is nothing of very complex. We can see we have that. We can reduce maybe some part, for example, we can see, okay, the disturbance. We can remove the wind because we go to apply our wind, okay. We can see our smoke is go up like this. Is nothing of more complex. I want to create this effects. For create my force I needed to create a free node. Free node is used essentially for create the large fluid simulation, and this free node is the microsolver. Microsolver, and you can say gas. You can see here all node with this kind of icon is the microsolver, and that should be used for create your system, your, for example, your simulation system. In fact, if you open, for example, that you can unlock, allow edit content, we can unlock, we can see here inside we have the gas fields. Is the microsolver is base for create your solver for your simulation essentially. In other words, I can go here. I want to create the microsolver is called the gas match fields, and this is create, rasterize, or and resample if necessary the data you can give to that. Okay. Another we needed is the microsolver is called the gas advected fields. These advected fields involve fields according to the specific velocity fields. It's very sound strange, but it's not. Don't worry, it's more clear soon. We can have the merge, and we can connect that in the force fields. Okay, force input here. With here, and if I press play now, nothing is changed. Okay, nothing is changed because we needed to setting our microsolver. Microsolver, we can start here. The first microsolver, we can say new val, because I created a new val, and is the reference fields is the val, the velocity we can create it. Obviously, we can say what kind of fields is that. Is a scalar or vector? Is vector. That part is, remember, maybe that part if you see for the first time, where you are setting, for example, the scalar or the vector, etc. And we can set in the default operation is set to always. I recommend to use set always, so it's calculate and check every frames every time without lost it. Here we can say our fields, new fields, is essentially my val, and the val is new val. Is that we can say take the fields val and is convert in the take the velocity fields the new val. Now if I press play, see nothing is changed, it's the same before. Okay, why? Because we should be setting with another solver, another microsolver, but it's essentially is the operator for working inside is the gas wrangle fields, that it's the wrangle for we can say okay left, okay, it's that it's the way for write your vex code inside the volume with the Pyro, okay. And here we can say, for example, we can start, we say v at val it's equals, okay. We can start to set, for example, the we can have, for example, the brackets, and inside I can say, for example, 0 dot comma, we can say minus, for example, 10 comma 2, okay, for example, and we can see what's happened now. We can see it's changed the direction, okay. But in this case it's changed the direction, is more uniform. I want to create a little variation. I want to create the best way for that. What I mean? I mean I can say here channel vector bracket open brackets, and I can call that new val, and then I can say the v at new val it's equals to my v at val, okay. In this way I click here, why is not okay, because I needed the don't space but the underscore, and it's create here these three parameters. These three parameters, I press play, I see nothing is happen. I can say minus 10 and 2. We can say it's like before, okay. But more interesting is that, for example, I think I can say if the float at density, because I take the density is the scalar is the float, it's more or less, but it's more of the value, the threshold. So I can say the channel, open brackets, I can say threshold, close the value, open this kind of brackets and close this kind of brackets, okay. Now if I press the channel, I have here the threshold. Now if I say the threshold, if the value is more like 1, press play, you can see I have the velocity. More of 1 is change, is continued that direction, but if I say is more like 4, I see when is 4 is go down, okay. I can say, for example, also up, maybe it's better to see. You can see here you can create your custom velocity essentially, and you can see is that is working like this. But you can do more. For example, you can also say, for example, if the velocity or the density, you can apply also the another density, you can change the velocity or multiply the velocity. For example, here inside this line, you can create more order here. You can say if we can say f at density is less channel threshold 2, open graph, okay, v at new val, you can say multiply equals, for example, 2, command dot, we can close this part, you can close this block here, and now we can see save, we can see what's happened now. Can create the block, I say less 0, I can say less, for example, can create the I can say here, for example, the threshold should be 0.5, for example, if minus of -1, okay, is more speed, if more 1, it's more 1, so if more 4, you can say, for example, here more 2, you can see what's happened now. Maybe we can, for better clear, I can copy that. I want to show you the difference here like this. Can remove it all part, okay, and I say, for example, 4, let's go up, but you see maybe yes, but I needed here this line here. You can see, okay, now if more 4 is started very quickly, so this is one kind of debugging. We can copy that part, or we can shake this. I want to apply that D here, and I want to see that better here. It's redundant, but I want to be sure it's working. You can say less 3, and here 4. You can see we have the different shape now. With one part is multiply, for example, the velocity, the new val, and then in another it's you can also write like this, that you can up here, because this is create essentially the attribute, the variation here, and I can say can comment here, comment here. Okay, now is better. It's working another way. Yeah, okay. You can see you can have that. Essentially, you can create the new wind with this kind of system, or you can also create another, for example, if you have a multiply for another value like 0, 0.2, you can essentially create the drag, essentially. That it's all. I hope you find useful this kind of lesson and this kind of tools. See you.